Welcome. Just give it 2 more minutes, then we can start. All right. Welcome into the second lesson. In this one, we will just jump right in. Most courses you will hear they will start with creating libraries, projects, and then create libraries and all that, and how to use them in your circuit. I will take a different approach. All right. What I will do is I will start right away with the schematic, and I'll give you a library to use. I'll show you how to import the library, and then we'll jump right into capturing a schematic. So we will go through it together. Okay. And once we're done with the schematic, we'll jump into the PC board. I will explain component placement for a very simple circuit board, and then we'll take it from there. Okay. So let's go. All right, so initially what you should have from what we did previously, we created a lesson one LDO PSU project like that, all right? And if you do not have it, what you can do is, well, first of all, before you even import the project, we had our design work group or project group over there. As you can see, mine is PCB design course, right? If this is not the same for you, I don't know which one you created. You have a personal one, but should you need it, go to right click on it like that and say open projects group, and it will lead you to your PCB design folder. I have two of them there. One, this is the one that I currently have. So I'm just going to double click on that and open it. All right. Now, if you open your design project group or your work group and you don't have your projects in there, what you can do is just say um, right click, open project, again, local project, navigate to your local project, select the project that you created the last time. So okay, or you can ultimately you can select browse and just again navigate to your PCB design folder and select the project. That's the project file, double click on it, and it will open. All right. Now, At this point, we shouldn't have any document in there. If you have one, right click on it and say remove from project and select delete file. Right click the file, remove from project and delete file. Say for instance you had a schematic like this, the name sheet one like this. All right, what you need to do is say right click, remove from project and say delete file. All right, now then you will have an empty project like this. Okay, great. Now in the chat I've given a link, a Dropbox link, where uh, you can get the files, the libraries, the templates that I'm going to be using in this project. All right, you can also find the very same link in the description of this video. You can just go down in the description, you'll find the link in there. Once you click the link, it will lead you to, let me open it up for you guys. I can show you exactly what's happening. All right, it will lead you to this folder, PCB learning folder. All right, I've got two folders in this Dropbox folder, library and templates. In there you will see I have, in the library you see I have 5-volt LDO learning, the one that we'll be using today. If I go back, and here I have template library and template folder. Sorry, I've got new project template and schematic template for course. So this is for our course. All right, so we're going to be using this very specific A4 templates. As we progress in this course, I will add more templates there, or we can even create our own, but we'll see how things go. All right, so now back to this PCB design learning folder in Dropbox. You can click on download and you'll see it says your folder is downloading. All right, and it's going to ask you to sign in or sign up depending on what you want to do. You can even just close it, because right now I can close it, and you will see that for me it has downloaded. And there we go, I got a PCB learning. It's a zip file. I can open it up. um Actually, let me open where it is downloaded. All right, so oh, no, I don't want to use this. Give me a second, guys. All right, say for instance I downloaded it into my, it's a zip file. I downloaded it into my PCBs and um, folder. I'm just gonna right click on it and say extract all, or just because of my current operating system, just click and right click extract all day. It's gonna bring up this window. If I want to see extracted file after I'm done extracting, I can just click on it like that. It's a tick there and say extract. And once it's done, come on, see it brings up this new folder. All right, inside there, let me close this. Inside there you see PCB learning. This is our zip file, but in there, after extracting, it created a new folder there like that. Okay, so I don't need this anymore. And inside this PCB learning, I can grab these two folders. I'm gonna cut them, and then I am going to paste them into my PCB design folder. All right, so I've got my library temp folder there, and I've got my template folder there. And of course, I don't need this anymore. I can just delete it to keep everything clean. All right, so what I do have now is lesson one there, my library folder and my template folder. This is what you guys should have. All right, let me delete that. You should also have, of course, your PCB design course um, Altium projects group file. Okay, so you should have 3 folders like that. Okay, great stuff. What I'm going to do next is show you how to import those the templates and the libraries into your Altium software. So first, what I'm going to do is Let's start with the template. All right, I'm gonna click there on my preferences up here, and I am going to go to data management and then template. In there, you will see that for me it's already set up, but if you want to set it up like this, what you need to do is just click on this icon there, click on it, it will open up the file explorer. So all I need to do is just navigate to my PCB design folder, select my template folder and say select folder. All right. Once I'm done with that, I'm gonna click on I'm done with that, I'm gonna click on apply and okay. And you will see these two files appear and then say okay. All right, now we've got our templates. Okay, great. The next thing you're going to do is click on over here on our neck on this tab here. You'll see, well, we got panels. Make sure that your component panel is enabled. If I click on mine opens the component panel on the side here. And then right now, I have the simulation generic component enabled, also miscellaneous devices and miscellaneous connectors. These are built-in libraries that Altium provides, all right? But what we're gonna do, we're gonna add the ones that we're gonna use for the specific lesson. I'm gonna click on that operation icon there, and I'm gonna say file-based library preferences. When I click that, this is what I get, all right? So it shows me the installed libraries. I have three tabs there: project, installed, and search path. What I am interested in is the installed library because I want to install a specific library. This becomes effective when we are working with a project that has its own set of libraries. But right now we want to install this library, or we can just say project add library because of the specific project. So we're just going to click on add library there, and here notice that it brings, or it comes right away into the library folder, all right, of my PCB design folder. And I'm going to click on that and say close. Once I do that, notice that everything is refreshed over here, and then if I click there, I have my 5LDO learning library enabled, and that's what I'm gonna use for the specific project. All right. um to quickly recap what we did, so we downloaded our template and library folders from the Dropbox link inside the description. All right. And then I extracted both folders and then put them over there in the same folder as my PCB design folder. All right. And then the first thing we did was to specify where to get our templates. To get our templates, we're going to go to sorry about that. We're going to go to our preferences and then local template folders over here. Make sure you have a server or local selected, and then under the local template folder, I am going to navigate to my PCB design folder and select go into template inside and select folder. All right. And then I apply, I say okay. All right. And the next thing I'm going to do is import my libraries. Go to my components tab, of course. If you don't have your component tab, go to panel, enable your component tab, and this is what it's going to bring. I prefer mine being on the last, on the left side. We saw this in our previous lesson. Um, and then, can you hear me guys now? And then I'm going to go to my operations icon, click there and say library file-based library preference, and inside project, I am going to say add library. navigate to my library folder into my PCB design folder as well. Select that and then say close. All right. Once you do that, it will refresh the component library tab, and then I can select my LDO lab integrated library like that, and then we are good to go. Great. One other thing I forgot to mention is if I go to my preferences and I should have a template setting somewhere. Let me search for it. All right, notice that under data management, I still have templates. No, 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 that's not what I want. Um, let's say library default location. All right, so under system default location, notice that I selected library path to be exactly where my library folder is. Okay. All right. And then document path, same as my PCB design folder there. So that means all my projects will be created in this PCB design folder. All my libraries will be found from in there. Okay. And the output jobs, I'll leave them like this for now. We'll sort that out. Normally, output jobs will be inside the um, project of every inside the projects folder of every project. Okay. So now we're good to go. We can start our schematic. Now, because you can see now that we added the library for the project, we have a library folder there with a compiled library. Okay, great. Remember, this star sign here shows us that this is not saved, so we can save it. Great. If we close our Altium now and reopen it, you will see that Altium will remember all of this now. All right. Now let's go on and add a schematic. So I'm gonna go to new. I'm gonna right click there and say add new to project schematic. Notice what happens. It brings this new schematic folder, right? But then I'm gonna go to template over there. And if I go to template and I select template, it's gonna bring this new dialog box here. This dialog box, and it's gonna say, do you want to update the template? Yes. I'm just gonna say just this document because I have only one. But if I had more and I wanted to apply this change to more, I'm going to say all schematic in the current project and so on, or all the open schematic documents. But right now, you will most likely only use just this document here. Okay. And over here, do not update any new parameters. Well, we don't have any parameters to update at the moment. We're just going to say, okay, click that. Template set to one document. And you will see now we've got a different schematic document there. How this template looks like, it doesn't really matter. It's not really important. We'll in the future we can learn how to set this thing up to whatever we want, but we're not gonna waste time on this right now. All right, let's just focus on capturing the schematic. Okay, so the one other thing I'm gonna do, I'm gonna just right click on this project. I'm gonna say rename, and then I'm gonna remove. Voila. Before I rename a project, it sees this schematic is unsaved. What it wants me to do is, before I do anything else with the project, it wants me to save the schematic first. So I'm going to call it power. Once I rename it like that, say power, save it, you'll see that my schematic name has now changed to power. And then over here, it wants me now to rename this specific schematic. Okay. So I'm just going to leave it to lesson 1 5-volt LDO for now and say okay. It says the system exists. Okay, good. Now we know what happens when we don't have already have a specific project with a same name. But now if I remove that and I just say 5-volt LDO PSU and say okay, it changes the name. But notice what happens, and this is the not so nice part about Altium. You see here the folder is still the same in lesson 1 5 LDO, because remember this folder got created when we created our project initially. So I'm gonna go in there, but notice the project got renamed. All right, and the project structure file got renamed as well, but the folder is still the same. Okay, if you ever want to rename this folder to match your project name now, Altium will throw a tantrum because Altium recognizes that this folder is in use, so you can't just rename things that are in use. To demonstrate, I will show you what it does. I'm gonna say rename like that, and if I just delete that, it doesn't want to, you see. However, if I go back and I close my Altium fully and I say save there everything, then I say try again, voila, it works. Okay, but now let's reopen Altium. You don't have to do this, I'm just showing you guys, but if you want you can follow. Let's reopen our Altium and see what happens now that I renamed the project. Okay, and I renamed the project and renamed the project folder. So normally, because the projects folder is different, Altium will lose the link to the project and therefore it will disappear from our project group. All right, which is fair because now it's not the same folder anymore where the project is located, it's a different folder. So to re-add it, I'm just gonna say play add existing project. I'm gonna select that, click over there, and voila. Here we have what we had previously. Yeah, great. Now let's capture our schematic. Okay. Mm, For that, I am going to need um, we're gonna need to open this. All right, now let's start adding the parts. Okay, so I'm gonna go to my component tab there, make sure that this is the correct library that is selected. And then the first thing that we're gonna do is I'm gonna look for, let's look for the first component. This is gonna be a connector because we want to use a specific connector for this. So what we're gonna type there is mini fit. So we're gonna use a mini fit connector, this one over here specifically. So I'm just gonna have to double click on it and bring into my schematic. Now notice that as I double click there, automatically this component gets attached to my mouse. I haven't placed it yet. All right. If I want to cancel this, I can either the right click or press the escape key. I right clicked, it canceled. Or if I want to place it, I can right click there and say place, right? Like that, that also works. But the fastest method is just to double click. Some people got very happy fingers. I am one of those people. You can click twice, but your mouse or your finger, you would want to click twice, but your finger does it 4 times. You see, this is what happens if you click more than once, or more than twice, I mean. It places it somewhere, all right? So whichever method works for you, double click. Here's go, I've got it. Now, I want to place this thing, but I want, let's say if I place it, this is how it looks like, but I don't want it like this. I want pin 1 to be facing the right side. So I have the option to flip it before I even place it or while I'm placing. So to do that, I just press the X key on my keyboard. Press X, it flips it on the X axis. Flips it horizontally. X again, X again, X again, X again. If you want to flip it vertically, you press Y, it does that. X, it does that. Like this, all right? So we're gonna place that like this, okay? And just to be fancy, I am going to move this text right here, for instance, okay? The next thing I am going to do is I'm gonna add a few parts. Give me a second, guys. First thing I'm gonna add there is one micro henry, no, not one micro henry, 1 microfarad cap, and the only one that shows up there, that's what I'm gonna select. Place one here and place another one there. Okay. Notice that as I place my components, for instance, the capacitor here, it has a designated C with a question mark. C with a question mark. What does that mean? This implies that we haven't assigned we haven't annotated the specific component yet, all right? So you will sometimes see in circuit C1, C2, C3, this is a placeholder for that number, C1, C2, C3, and so on, all right? So we've got capacitor, 1 microfarad, 0603, 16 volts, X7R cap there, okay? I'm gonna place two of them like this. Then I'm gonna take 1 ohm resistor, just type the 1R, 1206, that's what I'm gonna select there and dump it there like that, okay? And then I am going to say to put in a TL1963. Is this TL1963 or is it TK? Hold on, let me just say 1963 like that. What's this part again? Give me a second. One minute, guys. To open the schematic, the reference schematic I'm using. While I'm waiting for that, we're gonna add a ground. Let's add a few things, okay? So first of all, I am going to add, you see over there, there is a ground power symbol, all right? So I'm gonna click on that, and as I bring it, it brings the ground symbol there. I'm gonna place, before I do that, actually, before I place it, as it's still attached to my mouse, I'm gonna press the tab key on my keyboard. The tab key is the one right above caps lock, the one with two arrows in going in opposite directions, right above caps lock. Press that. Now, what happens when I do this? If I press tab before while I'm in placement mode, what it does is it gives me the property windows. That means I've paused my placement action. Now I can edit whatever property of the object that I'm about to place. All right. So for instance, if I want to press the ground symbol, but before I place, I want to edit a few things about it. I'm going to press the tab key. It pauses the placement. And then over here brings me the properties of this specific element. So I don't want to see this ground name everywhere to keep my schematic clean, for instance, but this is up to you or whoever you're going to be doing the PCB design for. But personally, I don't like seeing that. So I'm going to keep it, remove that iron and press enter, or click on that pause icon again and place one ground symbol here. Notice that the same properties apply to the next ground symbol. I'm going to place another one here, and I'm going to dump another one here. All right. And then press my escape key or right click. Okay. All right. The next thing I'm going to add is a resistor and my regulator. Okay. So I'm going to add another resistor here. That will be a 10 kilo ohm resistor. It's going to be an 0402, yes. I double click on that. And again, if I want to edit anything on this, I'm going to press the tab key. It brings me all the properties of the resistor that I can modify. But I don't want to modify anything there. I'm just going to click on that and say, okay, like that. All right, and next thing I'm going to add is the voltage regulator, which is LP38502. I'm gonna double click on that and dump one here. Okay, now this is a Texas Instrument 1.5 amp LDO. Okay, great stuff. Now I need a few more components to add this, so I'm gonna add a 68 kilo ohm uh, resistor, dump one here, I need a 8K2 resistor, 8.2 kilo ohm resistor. Just type 8K2 and dump it there like that. And then I'm gonna add a 1K resistor as well. I'm gonna add that on there. Now, why am I choosing this component specifically? It's because of the voltage that I want to achieve. So you have a voltage divider ratio that you need to apply to this adjust pin, putting a specific voltage there so that you can have a specific output voltage. Okay, it's the same as it works the same as an LM317. Okay, so another few more caps, 100 microfarad cap, like that. And I'm gonna add, let's add a bit more capacitance. I need to add a. All right, when you type the 47 microfarad, you see there are two. I have a 1206 and I have a, what is this? I don't know which size this is. Let me see. Oh, 805. So I'm gonna take the 1206 like that. And then I am going to add SMAG5 like that. Okay, and there we go, like that. This is what we've got. Okay. All right, so we still need to add a few things. Okay. We need to have more ground symbols over there. So now watch this, guys. If I click on my ground symbol there again, notice it comes with the ground thing hidden again. All right. Ultimately, you can just copy this, Control C, Control V, or a quickest way to copy is while you, if you wanna copy, let's say the symbol, while you wanna, before you click, you just maintain, you press your shift key, you hold down your shift key, and then you click and drag, it will copy. Click and drag, it copies, click and drag, it copies. This is an Altium designer perk. All right, great stuff. And then what I'm going to do is I'm just gonna grab this regulator, bring it over here, and then press X to duplicate it like that, and then again hold shift down, click and drag. I've got my, I can release my shift key while this thing is copied and place that ground symbol over there. So this is what we've got. Okay, great stuff. Okay, let's just put everything in the center because we've got space. Why not? Why have things up there if we can put them in the middle here? Okay. Notice there is a lot of things here that I haven't filled up yet, but we're gonna get to that. Okay, great stuff. Now we've got all the parts that we need for the specific schematic. All right. So what we need to do now is just connect everything and then annotate. All right. To connect, we need to put wires. Over there, Altium has an icon for wire. And as you can see, as I place my cursor there, it gives me a shortcut for it, Control W. Ultimately, I can go to place, wire. Again, it shows me Control W. Just click on there. And then I can start connecting. Now, let me zoom in there first. As you can see, I'm in the wire mode. Before I place my wire, notice that this small little X, but if I get to a pin, the X becomes red. That means it recognizes that this is going to connect to a pin. Valid connection from a pin. So I'm going to click once. I'll bring it out all the way to this other pin. Click once again. That's done. You see, the fact that I clicked once, it's done on another pin, it releases. But if I click in the middle of nowhere, there and there, you see, it doesn't release it. It will release only when I click on another valid net another valid net. By net I mean wire, or to a pin. Okay, that is basically what is happening there. Let me undo that. Same thing happens when I click there to there. I'm gonna link this one here. I'm gonna link this one there, over here, like that. Link this one there, this one here, that. Like this. Uh, and we go. Okay, one connection is left, that is there. So I'm just gonna move it from, I'm gonna move my ground symbol to connect there, and I move it down, it makes a connection. Or if it doesn't make this connection automatically, let me show you and do again. Okay, so I'm just gonna zoom in there and show you. If I move it there and I move down, for me it makes a connection that it automatically. This is an Altium setting. But if it doesn't, if I move it there and it doesn't move, if you move it away and doesn't make connection, what you can do is press Control down and move. Oh, mine is inverted. Okay, I see. Move it down. Oh, I see. I see. The setting is inverted. Normally, what I normally have is you move it, doesn't it connects, but you move it down, it disconnects. But if you press the Control key down, it keeps the connection. But in this case, we see that it's keeping the connection even if you move it down, which is perfect. This is what we want. Or you can just add, not be fancy, and add a wire normally. Okay. Now the tab pin there and the ground pins still need connection, so I'm just going to duplicate those ground symbols here and do that. Okay. Now one thing to note here. Notice that, oh, there's another connection missing there, sorry. Notice that I added as many ground symbol as I could, right? This is just to be clean in my design. I don't have to add so many ground symbol. What you will notice that if I click on this net here, for instance, it shows me physical name, net name, ground. Click on the next one, it says it says the same thing, physical name, net name, both are ground. Same over there, physical net name is ground, which means every piece of wire that has the same name is connected. This is a common theme in all the PC board design software, where two pieces of wire, this and that, for instance, this one and that one, that have the same name, they are automatically connected, which means if I give this name net ground, say this one wasn't connected, but this net's name is ground. Right now you see the net name is something else, but somehow if I change this net name to ground as well, if I can do that, I don't think I can. I can't. But if I somehow change this net name to ground as well, this will connect them. And in Altium, for you to change a net name, easiest way is to apply a net label to it. And the net label, let's say I do this. This is the net name that I want to change, right? So I'm gonna go to right click there and say net label. And now this is the net label that I want to place, right? Net label is basically giving a net a name, all right? Like you give a kid a name, I'm gonna give this net a name. I'm gonna call it GND, for instance, right? So if I place the GND net label on this track, and this is what happens. You see that there was a small letter X there, it disappeared. If I undo, this is not an X, I mean the red thing to tell me that there's a problem. Once I place the net label, it disappears. Now, notice that here this physical name is ground and net name is ground. This one also physical name is ground, net name is ground. I'm gonna press my I'm gonna place my cursor there. You see it says wire and net name, physical name, net name, ground. Wire, net name, physical name, both ground. See, so meaning the fact that these two wires here have the same name, they are connected. Okay, great. One other way to see that, but it's an option that I need to enable. I'm gonna go to preferences and then I'm gonna click on Insight. I'm gonna type Insight there. Insight is in under the system. I'm gonna say Design Insight. Um, yes, this is the option, Connectivity Insight. Connectivity Insight shows the connective relationship of net objects. This insight will show you previews of child sheets for sheet symbol, previews of net connectivity across the whole projects, and so on and so on. So basically, what does this mean? It means once I enable that, once I enable this option, it's in the system uh, design insight. Once I enable this session, right, and I hover my mouse for a certain delay, it will show me something. Connectivity insight. I want to, when my mouse hovers, I want to see document preview, object int, document tree. I also want my document tree and say apply OK. So now let's see if this works. You see, once I place my cursor on this wire, it shows me my schematic, and it shows me all the little, as you can see, all the little connections of that are connected to the same net. If I click there, you see it blurs everything else, but it highlights everything, the connection, the nets that share the same connection. All right. This proves to us that two wires, they could be physically disconnected or unconnected, but should they bear the same name, they are linked. Okay, that is why. That's also the reason why, instead of having, say for instance, if I didn't have this ground symbols, I would have had to do this. I put a wire like that, right? Now this becomes very unclean. Okay, some people prefer this, some others don't. I am among those that do not, but whatever you want to do, you can do. Um, it also becomes very important because in some circuits, ground is split through components. All right, so that will be very dependent on the symbols you use. We're gonna do that when we get to the point, like to that point. But for now, let's just leave it like this. Okay, just leave it like this. So we've got all the connections done. So I am gonna ask a question: are we still fine so far? Type it in the chat too. Great. All right. Now let's continue. Okay, so we basically done with placing the components on the schematic sheet and connecting them. Now we need to annotate. All right. To annotate is to basically number the parts. I don't know a better way to say that. Okay. So what we're going to do is we'll go to tools, annotation, and then we have two ways of annotating. The first one that I'm going to show you now is to annotate schematic quietly. This you will, well, in my experience, I've used this the most. The first one is to annotate quietly, and the second one is to annotate schematic. What I've used the most throughout my life experiences, where I work and all, is to annotate quietly. Okay, so once I click on annotate quietly, what happens is that um, it recognizes that there are 13 designators. The 13 designators, I mean, all these components have designators. So of all these components, 13 of them, in this case, all of them, which means all of them in this case, have designators requiring an update. Proceed with change, yes. Now notice what happened. Once I proceed with change, this is not R question mark anymore, it's R1. This is not C question mark anymore, it's now C2. That is what it means to annotate. Okay, so now we've got a perfectly annotated schematic, and then we are basically ready to move to the PC board, all right, with this schematic because it's completely done. There's nothing else we need to add. However, you might be required to describe a little bit what this is because your schematic might go to somebody that does not know exactly what's happening here or that does not have enough details, but or your schematic can end up in the hands of several other people. So you need to make it easy for them to see right away what this thing is all about, right? For instance, if I look at the schematic, I don't know that this is specifically a 5-volt regulator. I don't know unless I calculate the ratio here, then oh yes, it's a 5-volt regulator. You see, by applying a certain arbitrary input voltage here, or and reading whatever the, the data sheet of this thing is, right? So without that, I don't even know what's happening here. So we need to make that easy for the person reading the schematic. So we're going to add a few things here. So first of all, on that ground symbol, I'm going to right click and select place circle style power port. So circuit style power port, I'm going to click on that and I will bring it over here. But before I place it, I'm going to press the tab key. You see this says the name is GND. No, I don't want the name to be GND. I want the name to be plus 5V0, plus 5 volts. And I also want it to be seen like that. Okay, I want to see that. I click enter and then place one. The next one that I'm going to place is going to be this side, but I don't want to place the same one. As you can see, the first one is plus 5V0, but as I want to place the second one, this second one wants to keep the same name. I can press the tab key, edit the name there, say plus 12V0, like that, and place it. Or say, for instance, I placed it, but this is the wrong name, and I want to change it. All I can do is just select it there and go to the name and change it to the name that I want, plus 7 volts, for instance, 7V0, like that. And this is what I want, okay? So I'm gonna connect that there. I don't actually need to put a wire, I can just move it there like that, and move it there like that, okay? The next thing I'm going to do is, I am going to add text. So I'm gonna click on that letter A there, it says place string, click on that. And before I even place any text, zooming in again, I press the tab key while my text is still stuck on my cursor. That means before I place it, there I'm just going to see 5 plus 5V0, like that, LDO. All right. Now, I haven't even placed it yet, but I can see this text is a little bit too small. Press my tab key again. I will make that, let's say 18. Oh, 24. Perfect. I can make it dark. Oh, not gray, man. Black. And then make it bold, maybe. No, I don't need to make it bold. I can change the font to something that is suitable for your company. Arial. Perfect. For your work. All right, so I'm going to place it there like that. And immediately, by just looking at the schematic, this person knows that this is supposed to be a 5V output, 5 volts output, low dropout voltage regulator circuit. Okay, just by that, by doing that. Okay, so now it looks like something professional-ish, right? Great stuff. Um, I've seen some people have different kinds of things that they do to keep the schematic up to certain in-house standard. For instance, some people prefer, like, you have the designator, you have the value, and you have your footprint like that. Okay, you can edit those, you can move those around. By the way, remember our grid is 2.5 millimeter. Keep that grid to 2.5 millimeter at all time. If it's not the case, make sure that it is. You should see there like that, visible grade, snap grade, and snap distance. If you don't see the same grade, you just press the G key until you see 2.5 millimeter grade. We've set that up in our project in our previous lesson. Okay. So these small little squares that you see here are 2.5 millimeter grid. All right, guys. Perfect. So I will. You don't have to do this. This is just me, force of habit. So it's designator first. Not you. Designator first, value, and then package or voltage. Okay. This is just me. You don't have to do this. This is my own little habit. All right. In cases like this, where you might have, you see, for instance, this resistor, I have a resistor like this. And if I press 1206A and then I do this, say for instance, if this was C137, like this, all right? Or say you have an overkill project, you have so many capacitors, because that is very possible. Immediately, when you start printing this out on a smaller thing, this becomes a problem, all right? So what you can do here, instead, let me bring it back to C1. You can put this resistor here, resistor R1 designated there, the value over there, and then just like that, so that even if this designator is C1 million, at least it won't confuse you. All right. And that's pretty much it. And this is how you capture a schematic, guys. Today's lesson is about schematic capture, and we're gonna end it here. But before we do that, let's create our PC board. So I'm going to right click there and say add new to project PCB. All right. So in this PC board, as you can see, it has for now, let's just leave it like this. What we're going to do is let me actually look at the layers. Which layers do I have? All right, top overlay, bottom overlay. All right, let's not create the PC board. Let's just cancel this. Close. Okay, close this. I need to give you guys a PC board template for this so that we can have a certain set of rules and layers and everything. Okay, so we're gonna end this lesson right here, right now. If you have questions, you're free to contact me directly, or you can leave a comment. By contacting me directly, I mean those that have my specific um, contact details, my personal contact details. Those that do not have, you can leave a comment. And I say my personal contact is because most of the people that are watching right now are my own friends. But in the future, maybe some people out there will watch these videos. But in any case, should you need any more details, you can leave a comment. The next lesson should be on Sunday or Tuesday. Well, let's make it, I don't know. Mm, yeah, let's make it on Sunday. Next lesson is on Sunday night as well. And then there we will do PC board of this specific low dropout voltage. So the plan that I have, guys, is we do the schematic, we do the PC board, and then once we're done with that PC board, we take the very same schematic project and PC board, we add things to it. We're going to populate this. We're going to make this power supply circuit bigger and bigger for different voltages. And then, yeah, and that's how we will, um, and that's how we will complete the specific power supply design project. This is basically how we're going to learn the basics of PC board design and schematic capture. And then we'll take it further from there. We'll start including microcontrollers and high-speed devices and stuff like that. I'll teach you about differential signaling and all kinds of stuff, all right? But the initial stuff, we will go from here and then populate this more and more and more and more, getting it bigger and bigger and bigger as we move with the project, all right? Perfect. And then if everything goes well, depending on how things go, I will even teach you RF designs. All right. Until then, thank you for watching, guys, and please support. I don't have a mechanism for support. I'm kidding. But then, yeah, this marks the end of it. So thank you for being here, and I'll end the stream right now. Thank you. Pumai. Thank you, guys.